Okay, good morning children. Welcome back to ICAN Physics. So now in this class we are going to discuss about Kirchoff's laws, how it is related with the resistors in series and parallel. Let's see the class. Okay. Right. So the next question is, when two 2 ohm resistances are connected in parallel, then the effective resistance is dash. Okay. So for this question, I straight away go to the answer. After that, we will discuss something else. Okay. So when the resistors are connected in parallel, okay. So 1 and 2. Okay. So two resistors are connected in parallel. Okay. Suppose when it is connected with the external source, so that the potential will be same. The potential will be same. So when the current from the source, when it comes and here, so it is split into two. Here it will be I1 and it will be I2. So current will be differ I1 plus I2. Now these two resistances R1 and R2 are connected in parallel. Then what is the question? The effective resistance. So for that we can go for 1 by Rp equal to 1 by R1 plus 1 by R2. Now when 2 ohm. So what is the resistance of the first one? 2 ohm. What is the resistance of the second one? It's 2 ohm. So 1 by 2 plus 1 by 2. Half plus half 1 is 1 by Rp. Okay, now I put important sign. So reciprocal the value. So Rp equal to 1 ohm. So this should be our answer. Okay. The same question may be asked connected in series. Okay. So when it is connected in series, so that the resistance are connected like this. Okay. So when it is connected with the external source, here in this case, current will be same. Current will be same. So this is the resistor of resistance R1 and the resistor of resistance R2. Then the potential drop across the first one is V1. The potential drop across the second one is V2. So the total potential is sum of potential drop across each resistors. Okay, right. Okay, fine. Then the resistors are connected in series. Then the effective resistance in series equal to R1 plus R2. Now the value of R1 is 2 ohm. R2 is 2 ohm. Then we can write 2 plus 2 is 4. So the effective resistance in series, then it becomes 4 ohm. Okay. So for that, where we can get the idea? Here, the current flows and comes at this place, then it splits into two arms, I1 and I2. So for that, who gave the idea? So first, Kirchoff. Okay. So Kirchoff's deal with V, I and R. So already we are having V equal to IR, which is set by ohm. Here Kirchoff also deals with the VIR. So why we are in need of Kirchoff's law? Okay. So Ohm's law is applicable only for simple circuit. For Kirchoff's law is applicable for complicated circuit. Then Kirchoff gave two laws. First law and second law. The first law is otherwise called a current law. The first law is otherwise called a current law. So let us consider 1, 2, 3, 4, 5. So 5 arms. Okay. So 1, 2, 3, 4, 5 arms. So I want to consider second and fourth. The current is moving towards the junction. I2 and I4 are moving towards the junction. And the other arms, the current is flowing away from the junction. Away from the junction. Just see the arrowhead. Okay. Now, what is first law or what is current law? That is algebraic sum of current meeting at a junction meeting at a junction is 0. Algebraic sum of current meeting at a junction is 0. Okay. When the current is moving towards the junction has positive value. When the current is moving away from the junction has negative value. Okay. Just see the first current. Now this is the junction. Just see the arrow mark. It is moving away from the junction. So it is minus I1. Why? When the current moving away from the junction, which has negative value. When the current moving towards this junction, it has positive value. Just look at the current I2. I2 is the current moving towards. So plus I2. Now can you say what about I3? Yes, good. So I3 is the current moving away from the junction. So minus I3. I4 is the current moving towards the junction. So plus I4. Next, I5 is the current moving away from the junction. So minus I5, that is equal to 0. Now take all the negative values to the right side. So it becomes I2 plus I4 equal to I1. The minus I3 goes to right side as plus I3. The minus I5 goes to right side as plus I5. Okay.